In the previous module, we looked at the effect on the future value or the present value of a cash flow as we change the number of compounding periods in a year. If we start with the basic formula for the future value of a cash flow, and we assume the cash flow is $100, the interest rate is 10%. If we have annual compounding, then the future value after 1 year will be $110. If we have semi-annual compounding, we divide the annual interest rate 10% by 2 to get the interest rate per compounding period, and the number of compounding periods in 1 year is 2, and we can see that the future value increases slightly. As we continue to increase the frequency of compounding, we can see that the future value continues to increase, albeit at a decreasing rate. If we apply the same process to the formula for the present value of a single cash flow, $100 compounding once a year at 10% has a present value of $90.91, and as we steadily increase the frequency of compounding, we can see that the present value gets smaller and smaller, albeit at a decreasing rate. In theory, we can continue this process indefinitely. In theory, each compounding period can become infinitely small, and therefore the number of compounding periods in a year becomes infinitely large. What happens to the future value and the present value if the number of compounding periods in a year is infinite? In practice, of course, we can't actually perform this calculation. Anything divided by infinity is undefined. But there are some instances in finance where we do need to calculate a future value or a present value based on the concept of continuous compounding. Now, obviously no bank is going to continually calculate interest and add it to your account at infinitely small intervals. But there are some processes where it is relevant to talk about continuous compounding. For example, a share that gradually increases in price over a period of time, not as a result of interest being calculated, but as a result of the share gradually becoming more and more valuable. And we use the principles of continuous compounding in calculating rates of return on shares. The formula for the future value of a cash flow based on continuous compounding is this. In this formula, C is the present cash flow, as it was in our previous formulas. E is the base for natural logarithms. It's approximately equal to 2.7182818. And that number will be on your formula sheet. Some calculators have a button that will give you the precise value of E, but if you use this approximation, that will be close enough. Now, we can't use R because R is an infinitely small number. So to represent the interest rate, we use the annual interest rate, sometimes abbreviated APR for the annual percentage rate. We also can't use N because the number of periods is infinitely large, so we use Y to represent the number of years. Note that this calculation can be performed over periods of less than a year, and therefore Y will be a fraction. The formula for the present value of a cash flow based on continuous compounding is C divided by E to the power of APR times Y, where all of the variables have the same meanings as in the previous formula.